All right, hey guys, I apologize for not being in class today. I have to get some work done on my car, and the only time that they had was in the afternoon. Enough about me. Today, we're going to kind of move on to our next section here with the inequalities. And lucky for you, I believe you've seen this previously. So, we're going to go through these. I'm not going to do all of the examples because I don't think they're probably necessary, and I want you to be able to start on your assignment in class. So here's what we've got. All right. An inequality is a mathematical sentence that compares quantities. So it's a comparison. It's not an equal thing like an equation is. It compares two different quantities. There are four symbols here. I know that you guys probably maybe remember the little alligator thing or whatever animal in elementary school you guys dealt with, but because these are sentences that read from left to right, um, we need to know the names of these so we can read these inequalities correctly. So the first one that we have is less than. Okay. I remember this because less than points to the left. Okay. Um, to the right of that is going to be greater than. Okay. Um, and then the other ones that we have over here involve the less than and greater than signs. But this bottom half here, that is part equal sign. So what we will say then for this third one, this is going to be less than or equal to. And then the one on the right, instead of it being less than or equal to, it's going to be greater than or equal to. Greater than or equal to. So these are the inequality signs that we need to make sure that we are familiar with. All right. Now, the front side of this set of notes is one step inequalities, and the back side is two step. All right. So when we deal with these inequalities, we're going to do the same sort of process that we would have, or that we will do with equations. So with these one steps, you're just going to be using inverse operations. Okay. You're using inverse operations to isolate the variable, get that variable by itself. All right. So, for example, this first one, -6 is greater than or equal to n minus 5. To get that n by itself to isolate it, since that 5 is being subtracted, we'll add 5 to both sides to get -1 is greater than or equal to n. All right. Um, since we're solving for these and we're graphing these, once we have our solution like we have here, make your number line. So I'm just going to throw arrows on the bottom of this. And what I like to do is pick a couple different numbers, but I always start with my solution right here. Okay. To graph an inequality, we're either going to use an open dot or a closed dot, and that depends on what inequality symbol we're using. And then because inequalities, solutions to inequalities can be more than just a number. If it was just a number, it would be an equation. But since it can be more than just one number, we'll have to shade in the direction that makes our number sentence true. So what I like to do is pick a couple different numbers along those number lines there. Um, and then I like to test and see which ones work. So what I'm going to do is substitute these numbers that I just made on the number line in to the inequality. So I'm going to say maybe -1 is greater than or equal to -3, or -1 is greater than or equal to 1. All right. At the solution, meaning the number that we have at the solution, that is where we're going to put our dot, whether it be open or closed. If our solution can be the number, meaning this right here, if we can put -1 in for n, as well, we're going to use a closed dot. So if I read this as -1 is greater than or equal to -1, that's a true statement. So we'll use the closed dot. And really with that, the purpose of that is we use a closed dot when the solution, or to the solution of something that is either less than or equal to or greater than or equal to. Okay, so that's -1 can be a solution to this, which is not always the case. Now, to determine which direction we are going to shade, figure out which one of those small equations, inequalities, these guys here, which one of those is true. -1 is greater than or equal to -3, or -1 is greater than or equal to 1. The answer is -3. So we shade in the direction of whichever solution makes the inequality true. Okay? There's a whole lot of talking for such a simple problem, but that's all right. The next ones will move a little bit quicker. So going to the right, we've got 0.4 plus y is less than 7. Since we are adding that 0.4, I'm going to subtract it on both sides. Okay. This will cancel. Y comes down, less than 6.6. So my solution is at 6.6. So that's where I'm going to put this here. All right. And then kind of list a couple extra numbers here. And from there, I'm going to pick some easy numbers for my brain to handle. So maybe like a 10, maybe a 15 increasing there. Maybe this would be a 0 or a -5. Okay, so easy numbers there, in my opinion. Our solution is at 6.6. Can y, like this variable, can y be 6.6? If we substituted that in, it would read 6.6 is less than 6.6, and that's not true. It's the same as. So what we will do is we'll use an open dot at 6.6. So if I come over here, that's kind of the second half of when we graph these inequalities. So it can't be 6.6, but it can be, according to my inequality, can be less than 6.6. So again, I'm going to pick two numbers to compare like this. 10 is less than 6.6. Which one of those inequalities is true? Is 0 less than 6.6 or is 10 less than 6.6? In this case, 0 is less than 6.6, so that is the direction that we will shade. Okay? So those are two examples. I'm going to skip the next 4 because I want to get to the bottom 2 on this. So these work pretty much the same. There's one other thing that we have to take into consideration, okay? So as I'm solving this, think about, we've got a fraction here. That's a division problem. The inverse of division is multiplication. So I'm going to multiply everything by a -3. Okay? Multiply everything by a -3. Now what's going to happen is these -3's will cancel. The x will come down. 4 times -3 gets me a -12. However, when you multiply or divide an inequality by a negative, which is what we're doing here, okay, that was the -3. What happens is the inequality symbol must be reversed. Okay, so instead of this sentence reading or using the inequality symbol less than or equal to, it's now going to read greater than or equal to, because we are multiplying by a negative 3. Okay, we're multiplying by a negative 3. That's why that inequality symbol reverses. Okay, now that's my solution. Once we have the solution, we just need to graph this. Negative 12, I don't know, 5, 0, negative 15, negative 20. Those will work, okay? Since this is a greater than or equal to symbol, we are going to use a closed dot, just like that, right? And then if I pick two of these numbers to substitute in, which one makes the inequality true? There we go. Negative 20 is greater than or equal to negative 12, or 0 is greater than or equal to negative 12. The answer there is going to be the 0. So we're going to go that way. All right. Going to do one more on the right here. Negative 21 is greater than negative 3n. So from here, since that is a multiplication problem, we'll divide. And because we are dividing by a negative 3, this is going to, our signs will, our inequality symbols will have to be reversed. So instead of it reading greater than, it will read less than. All right? Setting up the inequality, our solution is at 7. About 10, 15, about 5, 0. Okay? Substitute in numbers for n. So we've got 7 is either less than 0, or we've got 7 is less than 15. This one's going to be the truth, so we will, we're going to shade in that direction. Also, this is a less than symbol, so we're going to have an open dot. We're going to have an open dot at 7, shade in the direction of 15. Okay? Now, if you want to try these other ones, I'll have those solutions up, but for the sake of this video, I'm probably not going to do them on this. We need to go to the back side. I've got 3 examples there, and then you can get your assignment. All right. So the back side is 2-step, and 2-step is done pretty much exactly like 2-step equations are. The first step that we have is we need to move our constants to the other side, and then use inverse operations. Okay, so it's like you're solving a 2-step equation. But it's in an inequality, so that's the only difference here. We have 3x plus 4 is greater than or equal to 16. First thing that we need to do is move our constants to one side. (16 minus 4 is 12. Since that's 3 times x, we divide. Divide by 3. Divide by 3. Cancel, and you get x is greater than or equal to 4. Now, the reason I didn't switch my inequality symbol here was because even though I did division, it wasn't division by using a negative. So that's why this still reads x is greater than or equal to 4. 4 is where my solution's at. Maybe 10, 15, 0, negative 5. Okay. Since my solution is greater than or equal to 4, we use a closed dot. And then if I pick 2 of these numbers and substitute them in, which one is true. And 15 is greater than or equal to 4. So we'll shade in the direction of 15. Okay. All right. I'm going to go to the right on this one, which I think there's, 6 questions on here. We're only going to do 3 because I really want you guys to get your assignment in. If you finish the assignment, and I'll put that on the board, if you finish your assignment while there's still time left over, I would like you to go back and practice these. Not that this set of notes is going to be graded, but it's never bad to do more practice. So anyway, first thing that we have to do on this is get our constants to one side. So I'm going to subtract 7. Okay, now this is a negative 2x. That's why I subtracted 7 instead of adding 7. That negative sign belongs to the 2. 11 minus 7 is 4. Less than. Those cancel. Negative 2x. Now on this one, this is like the ones on the front side, one of those bottom ones. What we are going to do in this is we are dividing by a negative 2 on both sides. 4 divided by negative 2 is negative 2. Those cancel, so we just have an x over here. But because we are dividing by a negative, our sign reverses. So instead of it reading less than, it would read greater than. All right? So set up your number line, negative 2, 0, 5, negative 5, negative 10. And then substitute numbers in. So, that's a greater than sign, so this is going to be an open dot. Say negative 2 is greater than negative 10, and negative 2 is greater than 5. Which one of those is true? Negative 2 is closer to the positives than negative 10. So this is true, which means we shade in that direction. Okay. The one last one that I want to do on this, and I'll have the notes and everything hooked up before the end of the school day. The last one I want to do is the one underneath of this. So it'd be this negative 8 is greater than x over 2 minus 5. So there's this. That is a negative 5. So our first step is to get our constants to one side. Okay. Now this is an interesting thing here. We have a fraction of x over 2, which that's going to be a division problem. So we're going to multiply everything by the 2. The question is, when we get a negative 6 on the left side and an x on the right side, does my sign reverse? The answer to that question is no. The sign will stay the same because the 2's that we are using are positive. So we are multiplying by a positive, not by a negative. So that's why our sign will stay the same on this. Just in case you were curious, I wanted to talk to you about that in person, but again, I'll be out. So that's something that we can talk about, though, tomorrow. All right? So our solution is negative 6 is greater than x. 1, 2, 3. So this is going to be a negative 6 in the center here. What's larger than negative 6 would be 0 and then 5. What's smaller would be like a negative 10, negative 15. Substitute in your numbers. Negative 6 is either greater than negative 15 or negative 6 is greater than 5. Which one is true? Again, for the similar reason to the previous one, negative 6 is closer to the positives. So we're going to shade in that direction. And since this is negative 6 is greater than x, let me put an open dot there and shade this way. Okay, that's what we've got. But yeah, that is it should be mostly review. Um, yeah, definitely should be review. I don't know what I'm doing right now. There we go. But try the assignment tonight. We'll go over it tomorrow, and if we have any questions on this, um, we can deal with those then. All right. I will see you guys on Wednesday.